Alright, so this is number 25. We're trying to find the equivalent capacitance of the combination of capacitors.
This is the given diagram we were given. At first, we freaked out when we saw this, but then we looked at
Our equations, and then we figured out that just reducing things and using the equations, it becomes pretty straightforward. And then just for finding series, you just add up the one, you add up 1 over the capacitance, and for parallel, you just add up the capacitance.
So for our diagram, we're going to start right here. We know these two are in parallel, so all you do is you add them up, and then you get this. You get basically a new diagram, which creates that.
Which now puts the two that were in parallel. They're now in series with 30, and then we also have the two up top, 40 and 24 microfarads, and they're also in series.
So for the top part, since it's there in series, you go 1 over CQ, which means 1 over 40 plus 1 over 24, gives you 1 over 15. But since it's 1 over, you end up just flipping this, so you end up getting 15. And you do the same thing with the bottom, with 1 over 30 and 1 over 70, giving you 21.
And then it's also reduced again to where now we have 21 and 15 are in parallel to each other. So you just use the equation, get yourself to 36,
Add them up.
and then you're down to the next diagram where 36 and 18 are in series.
Look how easy that looks.
And then do all the little quick math, and you get to 12, or 1 over 12, which gives you the answer, which is 12 microfarads.
Alright, for part B, we're asked to find a pair of capacitors with the same voltage, and in part A, we found that these two capacitors are in parallel, so we know that capacitors in parallel must have the same voltage, so for part B, these two capacitors are going to be the answer. Then in part C, we're asked to find two capacitors with the same charge, and in two capacitors in series, which are these two, will always have the same charge, so we know that that can be the answer for C.